Hello, good day. So this is the water quality and waste management course. So my topic today will be on about aquaponics, specifically on nitrogen waste and management. This is the case study, one of our tasks in our course. So to start off, let us look at the content. We have an introduction. The second is the waste nutrient. Third is the nutrient balance and access. And the last one will be the recommendations. So to start off with the introduction, aquaponics is the potential sustainable food production system that integrates aquaculture with hydroponics, in which nitrogen-rich effluents from the fish production is utilized for the plant growth. It covers three major entities, which is the fish, the plants, and the microbial community. And there are three types of aquaponics, which is called nutrient film technique, NFT, the floating raft deep water culture, and the media field flood and drain. Feed is a major source of ammonia in the culture system because the fish can only absorb 20 to 30% of the nutrient from the feed, while remaining is excreted into the environment in ammonia and organic protein form. And then plant and bacteria play a role in sewage purification. Nutrient-rich waste function as a fertilizer for plant growth, whereas nitrification bacteria associated with the roots of the plant and play an important role in the nutrient cycle. So the thing that caught my eyes during this for the case study is what is mentioned in Record C 2007. He says that the expense of water quality monitoring is reduced in aquaponic system as waste nutrients are generated daily at uniform levels and there is generally excess wastewater treatment capacity. So the thing that I have that I look into through my farm visit to get more understanding of this aquaponic system is that from the word we can see what is waste nutrient. So I will focus in nitrogen waste. And second, what is the balance, meaning that how much is produced and how much is taken up. And what does he mean by the excess, meaning that how much is excess and what happened to the excess. So what is waste nutrient? Waste nutrient is this, I can say it is we are focusing into these three things: ammonia, nitrogen, nitrate, and nitrite. So according to Timmons et al. 2002, the major source of nitrogen input in aquaponic system is fish feed, which is excreted by the fish in the form of ammonia nitrogen. So it is 90% of it. So the rest will be nitrate and nitrite. So this is the general flow of what is happening. So you can get any of this information of the flow of the nitrogen cycle in online. But what we see here is in aquaponic, total ammonia nitrogen needs to be oxidized to nitrate because nitrate is not toxic to fish even at high concentration of up to 150 to 300 milligram per liter. But however, total ammonia nitrogen and nitrate is have to be maintained at low level because it is toxic to the fish. And this is one of the flow. The first one is the now tilapia at cage production. So you can see how the feed input of 100% and then how much they consume and then how much is retained and how much is become feces and soluble excretion in the form of nitrogen waste and phosphorus waste. But our focus will be on the B side, which is the recirculating aquaculture system. So from 100% of feed input, we assume that 100% of consumption will be on nitrogen and phosphate, and then there will be roughly 15% to 15 to 50% of retention in the body of the fish, and the balance will be coming out as feces and soluble excretion, and then there will be what you call sludge and total excretion. So in what do you call balance in the system, so I have seen that balance is like nitrate is they will be called nitrate accumulation and nitrate depletion, which accumulation means the generation rate is higher than the uptake rate by the plant, and the depletion is the uptake rate by the plants is higher than the regeneration rate of the nitrate. So according to Snow and Gully, this is the decreased nitrogen waste in aquaponic system. So for ammonium, it is around 55.9% to 76%. Nitrate is 34% to 54%. And nitrite is 49.6% to 90%. How come nitrate is high? Because you need nitrate to be converted into nitrite. So nitrogen uptake rate is influenced by many factors such as nutrient concentration, light intensity, humidity, temperature, and ambient carbon dioxide concentration. Nitrate uptake rate by plant is higher than other nutrient uptake rates, such as calcium, magnesium, and kalium. Insufficient nitrification is a major problem in biofilters, especially during the startup period, leading to the accumulation of nitrate. The supplementation of commercial viable nitrification bacteria together with low circulation rate during the startup period can also accelerate the nitrification rate. The nitrogen transformation between the vegetable biomass and gas loss are affected by microbial growth on the surface area of the plant roots, carbon source for microbial consumption, and contact time, which is affected by the water flow rate. The preference of ammonium and nitrate depends on their concentration, growing stages, and plant genetic factors, thus making it difficult to model nitrogen uptake by plant. And then after knowing how much nitrogen was taken up and then the balance of it in the system, so the next question is, what happened to the excess of the nitrogen waste? So one of the point that I want to highlight is the nitrous oxide emission. So nitrous oxide is a potent greenhouse gas with global warming, and aquaponic system generate nitrous oxide around 1.5 to 1.9% of nitrogen input. Nitrous oxide is generated in both anoxic and aerobic condition. It is induced by several conditions such as insufficient denitrifiers population, nitrate inhibition, oxygen inhibition, insufficient organic carbon, which is the plants or the animals, and also the low pH. So in aerobic condition, this nitrous oxide emission from aquaponic system also can occur during ammonia oxidation via nitrifier denitrification in the grow bed and in the biofilters also. For anoxic condition, under low dissolved oxygen condition and abundance of ammonium in biofilters. Nitrifier denitrification coupled with ammonia oxidation can significantly contribute to the generation of NO and N2O in the presence of Nitrospira and Nitrosomonas europaea. And the recommendation that is to stop or to lessen this nitrous oxide is that aquaponic system can have been recommended to be an alternative method to reduce NO2 from the aquaculture system through nitrogen assimilation, which is mentioned previously, how we balance our nitrogen actually, and it will be further elaborated on the recommendation later on. So for the recommendation, I have searched through most of the system that is available and even went to the farm visit. So these are some of it that can be useful to improve or to maintain our the problem of this management of nitrogen waste in aquaponics. So the first one is the dissolved oxygen. We have to make sure that the concentration of dissolved oxygen is sufficient for microbial growth in biofilters and root of the plant. How to do it? We apply aeration with acetone at biofilter area and the plant root area. Second is the alkalinity. It has to be around 100 to 150 milligram per liter, and we are using calcium carbonate or calcium bicarbonate. For the fish stocking and feeding, it is following to the thumb rule of 1 fish to 8 gallon of water, or 1 kilo of fish per 15 liter of water. And we have to avoid overcrowding and overfeeding, and also we have to remove the uneaten feeds. For the temperature and algae growth, we can use shading or roof, while mechanical filter is used also to remove the algae growth. For the pH, nitrous oxide is emission is in the aquaponic system at low pH condition were reported to be higher than in neutral pH condition due to the inhibition of functional genes such as genes encoding ammonium monocyclinase, nitrate reductase, and nitric oxide reductase. So how are we going to increase our alkalinity, increase our pH? We are using potassium hydroxide and calcium hydroxide. And then next is the biofilter, the plant, and the nitrifying bacteria connection. So this process is after the solid waste removal, where we need to have sufficient amount of biofilters, amount of plants, and then the amount of nitrifying bacteria in the community. So you have to try your best to get the balance of this, how much biofilter needed, how much plant needed, and how much nitrifying bacteria needed in your system. So the conclusion that I can suggest is that plant and bacteria in aquaponic plays an important role in processing of nitrogenous waste. Building and maintaining an aquaponic system can be challenging at times, as many variables needs to be considered. However, once you have established a system on maintaining your aquaponic system, everything will be easy, and do not be discouraged by the problems that you will encounter, as we all learn from our mistake or experience. So this is the reference, a few important reference that I have been using. So thank you for watching. Bye bye.